For the max scale property, we will of course need to exchange the height properties for the width properties. So mapSize.width and frame.size.width, which will make sure that we can't zoom out so far that we can see the background of our scene. I also gave you a small assignment to clean up your pinch method a little bit, using extensions for the CG_Point class to allow for easy addition and subtraction. So let's go into our configuration file where I can now add two new methods, starting with static public func plus with a left CG_Point parameter and a right CG_Point parameter. It will of course also return a CG_Point. All I need to add to the method body is return CG_Point with the x value being left.x plus right.x. And for y, we'll say left.y plus right.y. So we are just adding the x values and y values of the past points for our new one. And just like that, we will implement static public func minus with the parameter left as CG_Point and right as CG_Point as well, where we will again return a CG_Point. In this case, we will return a CG_Point with the x value left.x minus right.x and the y value left.y minus right.y. Alright, that's it. I can now go back to my game scene and take a look at my pinch method, where we can now replace some code. The location delta constant is basically just subtracting location after scale from location. So instead of all this code, I could just write location minus location after scale, which looks a lot more sophisticated and cleaner. New position is just adding location delta to our game camera's position, which I can now write as game camera.position plus location delta. I think we can all agree that this method now looks a lot less cluttered and is much easier to understand. While this doesn't really change anything, I think it is often nice to spend a little time to make your code more understandable. So maybe when you return to your code after a few weeks or months, you instantly are able to see what exactly which method does and how you intended to use each method. I hope that some of you were able to solve these small challenges, and if you had any problems, just let me know. We now have a pretty solid basis for our game. We have a map in which we can pan around and even zoom, all while being constrained to our tile map, so we don't see any backgrounds of our scene anymore. But we do want to create an Angry Birds game here, and not just a scene that we can look at. So I guess it's now time to add a bird to our game, or at least a placeholder for a bird, so that we can then start working on the mechanism that we need to launch the bird into the air. We will add our bird inside of the game scene later, but for the bird itself, I will of course create a custom class, since it will have some custom properties later on that we're then going to use for different things such as flying animations and such. I will therefore create a new file in my custom nodes group. It will be a Cocoa Touch class and a subclass of SKSpriteNode, since we of course want to see our bird, and I want to assign a texture to it to make sure that we are really able to see our bird. I will call my new class bird, and I can then just create it. As always, we start by importing SpriteKit at the top to make our error disappear, and I can then begin implementing the bird class. In the end, we will have 4 different birds in our game, and all of which are going to have different textures. to be able to differentiate between the 4 birds and their respective abilities. Above the class, I will create a new enumeration, which I will call bird type. I want to add a raw value of type string that will allow for some pretty nifty coding later on. For the cases of my new enumeration, I will add red, blue, yellow, and gray, since these are the 4 colors our birds will later have. So it makes sense to name these cases like this. If I do not add an explicit value for the raw values of the enumeration here, the raw value will just be the exact string of the cases. So in our case, the strings red, blue, yellow, and gray. Alright, with our enum in place, I can now begin implementing the bird class. As of now, it will only have one property, a constant called bird type, which will of course have the type of our newly created enumeration bird type. This can be a constant because if we have initialized the bird once, it will obviously not change its color anymore. I will then have to add an initializer since this property has no default value. So let's create an initializer here with one parameter called type bird type, and inside I will then just set bird type to this parameter. Let's also select this fix Xcode proposes for adding the required initializer so that our error vanishes and I can then continue working on my initializer, where we ultimately have to call the superclass initializer. But before we do that, I'm going to add a switch statement to check which color our bird should have. I will define a local constant called color, which will be of type UI color. I will add an exclamation mark, so I'm going to explicitly unwrap this value. I can then write switch type to check the value of our parameter. I will then add all the cases from my enumeration, beginning with the case red, in which I will just set color to a UI color.red. The case blue will be set to my color constant UI color.blue. Next is the case yellow, in which I will set color to UI color.yellow. And finally, the case gray, which will of course have the UI color.light gray. I do not need the default case here, since I have explicitly added all the cases of my enumeration, so the switch statement is exhaustive. I do now know what color my bird should have and can use this information with my superclass initializer. We are going to call super.init with the parameters texture, color, and size. For now, I will just pass nil for the texture to simply test our birds with a colored shape. For the color, I will of course pass my color constant. And for the size, I will pass a fixed CG size. With the height and width set to 40.0. That should be it for our bird class. And we can now go back to our game scene where we will add the bird to our actual game. We will obviously come back to this class to add more stuff to it and ultimately provide an actual texture for our birds so that they are not just colored squares or sprites like we have them currently initialized. But to test some basic functionality, this will do. So let's jump back to the game scene, where I now want to add 2 new properties. The first will be a variable called bird, which I will just set to a new bird instance with the type .red, so that we have a red bird initialized here by default. The second property that I want to add is a constant called anchor, which will be an empty sknode instance. we will use this anchor property later on to be a fixed anchor for our birds, where they should spawn and from where we will launch them. Especially for launching the bird with this slingshot mechanism, we will need some kind of reference point or anchor to calculate the force we will need to apply to the bird. We will already implement it now so that we are able to position our birds properly. Let's jump into the setup level method, where I now want to, after adding our camera, set the position for this anchor node. Therefore I write anchor.position, and I want to position this anchor in the first quarter of our scene. Since the anchor point of our scene is at 0, I can get this quarter by using the frame mid properties and dividing them by 2. So let's set this to a ZG point. And for the x coordinate, we will say frame.midx, which would be the center of our scene. And if I now divide this by 2, we get a quarter. Same goes for the y value, so frame.mid_y divided by 2. I can then use addChild to add this anchor node to my scene. Next, I want to add my bird, but this will get a custom method in our scene, which I will define below the addCamera method, and it will get the name addBird with no parameters. I can then call this method right after adding my anchor from the setup level method. This addBird method will now just get a very basic implementation, but we will come back to it later to add things like physics and such. But for now, all I want to do is specify the location of our bird and add it to the scene. So let's write bird.position, and I will just set this to anchor.position, since this is where we will spawn all of our birds. And I can then use addChild and bird to add our bird to the scene. And if I now run the app, we should hopefully see our bird, which as of now obviously just will be a red square. Alright, the X position seems to be pretty good, but our bird is a little close to the ground here. And actually, if I see this here, it looks like this is going off our camera's frame and not the frame of our actual level, which would be the map node. So let's stop this. And for the anchor position, I want to go off our map node. So map node.frame.midx and map node.frame.mid_y. So if we now run the app again, it should actually be in the first quarter of our map and not just the current camera frame. Okay, that's exactly what happened, and we have our birds right where we want it to be. If we do this depending on our map node, this has the nice effect that it will also work across different devices, so that our bird is always positioned at the same spot in our game and not somewhere else just because the camera frame is a different one. We now have a bird in our game, well, at least a placeholder for our bird. However, we are not able to interact with it yet. So we should now think about how we can add the possibility to drag our bird back and then launch it forward into our scene when letting go. To do this, we will now have to work on a lot of things like physics constraints and finally add the functionality for our camera to follow the bird as soon as we launch it. So let's get started.